This is chapter 2, which is chemistry of outer transition elements, that is part of inorganic chemistry. And the topic that we will study today is from the general properties of the transition elements, that is the variable oxidation state. Before I give you a detailed analysis of the topic, I'd first like to explain you this table that you have in your curriculum, which shows the oxidation states of the elements of the 3D series. By 3D series, it means the elements of the fourth period, and we will study the elements scandium to zinc. In this table, along with the elements, you have their outer electronic configuration as well as the oxidation state. You can see that there is variable oxidation state for the elements of the 3D series. For scandium with the outer electronic configuration of 3D1 and 4s2, it shows +2 and +3. For titanium, it shows +2 till +4. And then the oxidation state increases from scandium to manganese. For manganese, it shows from +2 to +7. And then you see that it is decreasing from iron to zinc. Here you can see easily that the key point is that the outer electronic configuration, as we have already discussed, contains two orbitals or consists of two orbitals, which is the 4s and 3d orbitals. You can say that the oxidation state increases from scandium to manganese and then decreases to zinc. Second thing that you can observe from this table is that along with the variable oxidation state, the least oxidation state is for copper, and that is +1. The most common oxidation state for all the elements is +2, and the highest oxidation state that we get for the 3D series or the fourth period is for the manganese element, and it is +7. If there is variable oxidation state, so there must be a scientific reason behind it, as you have already studied in the table that two orbitals involved were 4s and 3d. So those orbitals have very small energy difference between them, therefore it leads to variable oxidation state. Keep in mind that 3d and 4s orbitals, both these orbitals are involved in the bond formation of the transition elements. Talking about the range of the variable oxidation state, as the least one is the +1, that was for the copper, and the highest is +7, that is for the manganese. You get this question in your board examination when they ask you that what is the reason behind the variable oxidation state of the transition element or the 3D series or D block. They can rephrase the question, but the answer will be same. The answer is that there is a small energy difference between the 3D and 4s orbital that results in the variable oxidation state of the transition elements or the D block elements. You get this in your multiple choice question that what is the range of the oxidation state for the 3D series, or they rephrase it as the outer transition elements or the fourth period. The range will be from +1 to +7. It means depending on the element, it may show the oxidation state +1, +2, +3, +4, +5, +6, and a maximum to 7. Now the trend for the variable oxidation state, as we have discussed in the table, that there is an increase in the oxidation state from scandium to manganese. Then you see a decrease in the oxidation state up till zinc. It means from scandium to manganese, the oxidation state will increase +2, +3, +4, +5, +6, +7. But then from manganese and forward till zinc, it will decrease +6, +5, +4, +3, plus 1 2, that is for the copper, and then again plus 2 for the zinc. As stated earlier, the most common oxidation state is the plus 2 that all transition elements of the 3D series shows. The highest is the plus 7 that the manganese element only of the 3D series shows. And the lowest or the least oxidation state is for the copper, and for copper it is called as the cuprous, that is plus 1. You might get this in your multiple choice question in which they ask that manganese shows the highest oxidation state, and you get 4 answers in which you have to select the correct answer. You get plus 5, plus 4, plus 3, plus 7. So you know that manganese shows the highest oxidation state, so you will select plus 7. For cuprous, it will be plus 1. And if they ask about the common oxidation state, then the answer should be plus 2. So make sure that when you are attempting such questions, you are thoroughly reading the question, that what exactly the question is asking for you, and then when you know the question and you report the answers, you will get full marks for it. This is an important question. You get this in your short question answers for the explanation, and you also get this in your multiple choice question. I will make a detailed video on the board inter that you get for the topic from this particular topic in your board examination. A self-assessment question regarding this topic is that why the transition elements show variable oxidation state, and what is the reason behind it. Just keep the table in your mind. In table we have all the elements having the 3D and 4s, and you can easily correlate it that there is a small energy difference between the 3D and 4s orbital. That is why they show variable oxidation state. Just the keyword, or you can rephrase the sentences, you can get full marks. There is no need at all to write multiple paragraphs. Write as per the requirement of the question. This is just a question that you get in your short question answers, and that is also in the reasoning that I will discuss in the video ahead for 4 marks. So you get 4 questions, 1 mark for each question. You write the keyword very small energy difference between the 3D and 4s orbital, and you get full marks for this particular question. This is all for today. Thank you so much. I will make the next video on another property of the transition elements. Thank you.